Hi everyone, welcome back to another video in the Web Security Academy series. In the previous video, we covered the second lab in the SQL injection module. So we got some hands-on experience by exploiting a SQL injection in the login functionality of the application. That allowed us to bypass authentication, and eventually we were able to log in as the administrator user without knowing the administrator's password. I've added the link to the previous video in the description if you want to check it out. In today's video, we'll be covering lab number 3. This lab will leverage a SQL Injection Union attack that will allow us to extract information from the backend database. All right, let's get started. If you do not have an account, you can get one by visiting the URL portswigger.net/websecurity and clicking on the sign up button. I do already have an account and I am logged in, so to access the Academy, I'm going to select Academy, go down, select the learning path, select SQL Injection, select SQL Injection Union Attacks, and then click on the first lab. And it's titled SQL Injection Union Attack, determining the number of columns returned by the query. So let's open that in a new tab. All right, let's look at the description. So this lab contains a SQL injection vulnerability in the product category filter. So we've got an SQLi and it's in the product category filter. The results from the query are returned in the application's response, so you could see them in the browser. And it says, so you can use a union attack to retrieve data from other tables. We'll learn what that is in a second. The first step of such an attack is to determine the number of columns that are being returned by the query. You will then use this technique in subsequent labs to construct the full attack. All right, so what this exercise is saying is that you've got a certain parameter, the category filter, that is vulnerable to SQL injection. Now, the way we want to exploit this filter or this category parameter is by running a SQL injection union attack and eventually being able to retrieve data from other tables. So we're not interested in, for example, the products table. We're more interested in tables like a users table that contains the authentication credentials to the users of the application. So we'll perform a union attack that will allow us to retrieve data from other tables. However, this is not done in one step, it's done in multiple steps. And one of the first steps in order to exploit this vulnerability is to determine the number of columns that are being returned by the query that filters on category. And then once we're done that step, there are a couple of more steps that will be done in subsequent labs in order to construct the full attack. So in order to learn how to run this attack, it's gonna take, I believe, about 2 or 3 videos before we can actually extract data from the backend database. All right, so the end goal over here for today's exercise is to solve the lab, determine the number of columns returned by the query by performing a SQL injection union attack that returns an additional row containing null values. So the end goal is to determine the number of columns returned by the query. And we'll do that by exploiting the SQL injection vulnerability. All right, so before we access the lab, we need a little bit of background knowledge on how the union operator works. All right, so take, for example, you've got 2 tables, table 1 and table 2. Table 1 has 2 columns, A, B, and table 2 has 2 columns, C and D. Now, table 1 contains the values 1, 2. Table 2 contains the values 2, 3. And then table 1 also contains the values 3, 4. And table 2 contains the values 4, 5. Now, imagine you have this query over here. Select A and B from table 1. So select columns A and B from table 1. The result of this query would be the values in those columns. So it would be 1, 2, and 3, 4. Now, let's do a query that uses the union operator. So the same query above, so select A, B from table 1, union, select C, D from table 2. All right, so what the union operator does over here is it concatenates the results of the two queries into a single result set. So it'll run the first query, select A, B from table 1. So the result is 1, 2, 3, 4. And then it'll concatenate that result with the one of the second query, with the result of the second query, which is select column C and D from table 2. And that would be 2, 3, and 4, 5. And the results are displayed into one single result set, so in the same table. All right, so now you might be wondering, well, how does this relate to a SQL injection attack? Now, imagine you have this query over here, and all it does is it displays products from a product table. Now, I'm not interested in seeing the products in the product table. I care about more tables. For example, the users table that contains the username and hashed passwords of all the users of this application over here. And so what I can do, if this is vulnerable to SQL injection, I can add this query over here. Let's say it's a users table. So I'll inject this query over here that says, don't just give me the products in the product table, but also give me the usernames and passwords from the users table. And this way it allows me to extract information from other tables that are being used by the backend database. Now, before we even get to the SQL injection attacks, it's important to know that there are certain rules that you need to follow when you're using the union operator, and we'll get those from the official Microsoft documentation. Union operator SQL. So if you go down, you could see over here the function of the union operator is that it concatenates the results of two queries into a single result set, just like we saw for those two tables over here. And then it says the following are basic rules for combining the result sets of two queries by using union. So the first rule is that the number and the order of the columns must be the same in all queries. And we saw that this is the case for our query over here. So the number of columns that were called in the first query are 2, A and B. And then the number of columns that are called in the second query from table 2 are also 2, C and D. So we satisfy this rule. And the second rule is that the data types must be compatible. And we saw over here all the columns A, B, C, and D are of type integer, and that's why this query works and doesn't throw an error or an exception. All right. Okay, now that we know how to use the union query, how can we apply it in order to achieve our end goal, which is to determine the number of columns returned by the query? So let's say SQL injection attack. Imagine you have an application that is running a query at the backend. However, because you're doing a black box pen test, you don't have access to the code and you don't know the number of columns that are being used in that query. So let's say question mark over here, and it's from, say, table 1. Now, if this query is vulnerable to a SQL injection, you can use the union operator in order to determine the number of columns by iteratively doing a bunch of requests that determine the number of columns. And the way we're going to do that is we'll do union select null value. Now, if the number of columns is not the same in this query, so in the second query over here, if the number of columns is not the same to the number of columns that are being called in the first query, then we'll get an error. And if we get an error, then we know that the number of columns is not just 1. So we know that it's incorrect number of columns. And so we'll keep running this request over here iteratively until we no longer get an error. So instead of using one null, we'll use 2 null values. And again, if you get an error, that means the number of columns over here is incompatible with the number of columns over here. And so you still haven't gotten the correct number of columns until you keep iteratively doing this. And then if you end up getting a 200 response code, then you finally reach the correct number of columns. And we'll see how to do that in the exercise. All right, so that's way number 1, and that is how Swigger wants us to complete the exercise. But there is a different way, which is a little bit cleaner. And let's learn that as well. So let's say way number 2. And what that uses is the order by clause. So let's say order by SQL. And again, we'll look at the Microsoft documentation. So it sorts data returned by a query in the SQL server. All right, so if you've got a query that says select AB from table 1, and then it says order by 1, what that will do is it will order by the first column. If I said order by 2, it'll order by the second column, which is B. If I said order by 3, that column does not exist, and so it will throw an error. And this is another way of determining the number of columns that are being used by the query, because what I can do is I can iteratively keep increasing this number to, 1, 2, 3, 4, so on until I get an error. Once I get an error, that means the column that I'm trying to order by does not exist, and therefore this gives away that number of columns that are being used in the query. And so we'll do both methods in the exercise. Right, I'm going to close this. And let's access the labs. And this might take a while. Okay, so it looks like we've got a shopping application. You can refine your search based on category. So this is the field that is vulnerable. If we look back at the end goal over here, this is the field that is vulnerable. So if I select gifts, it'll only show me the items that are related to this category. So the items that are related to gifts. And if you look over here in the URL, this is the category parameter, and this is where it gets filled out. Now, since this is the field that is vulnerable, I'm just going to run a basic test case, so a single quote, to see if it breaks the application. And it does. So we get an internal server error. This leads me to believe that it's vulnerable to SQL injection because what happens is that I introduced a character into the SQL query, and it threw a syntax error, which resulted in an internal server error. Now, to confirm that it is vulnerable to SQL injection, I'm going to give it a value that is correct, so it won't break the query. So I'm going to comment out the rest of the query. And if that returns a 200 response code, then I'm convinced that it is vulnerable to a SQL injection. All right, so that's good. Let's go back to our general use case, which is just selecting gifts. All right, so now I need a way to determine the number of columns returned by the query, as the end goal states over here. And we learned 2 ways. Let's apply way number 1, which uses the null values. So I'm going to close the query over here and say union select null. and hit enter, I get an internal server error, which leads me to believe that there isn't only one column in the query. And that makes sense because it looks like, just based on the information that is displayed in the response, it looks like the query has to have at least a column that displays the name of the product. It also has to have a column that displays the price of the product and a column that uniquely identifies the product. So some kind of ID column that is not getting displayed in the response. And so my guess is it has 3 columns, but let's apply this attack iteratively so that it works in every use case. And to do that, I'm going to use Burp Suite. For those of you that don't know what this is, it's a proxy that sits in the middle between my browser and the application. And this way, any requests that I make in the browser will get intercepted through Burp first and then get sent to the application. Similarly, any responses that come back from the application go through Burp first and then to my browser. I'm going to click no over here. Oh, let's close it. Yes. All right. I'm going to tell my browser I'm using a Foxy proxy extension, and I'm going to tell it to use Burp as the proxy. And I'm going to hit enter. And you'll see over here it intercepted the request. I'm going to send that to repeater and remove the intercept, turn it off. Okay, let's go to repeater. All right, so over here, let's make that a little bit bigger. All right, so over here, we exploited the SQL injection by saying union, select null, and then comment out the rest of the query. And then you need to URL encode that. The browser does that for you, but in this case, you're using the proxy, so it's Control U. And then hit send. And then in the response over here, you get an internal server error. And let's put that side by side so that we could see it. All right, so over here we added only one column and it was incompatible with the backend query that does the filtering. And so it gave us an error. Now let's add another one and see if that works. So for the space, we'll just add a plus. We still get an internal server error, so it has more than 2 columns. Let's add another null. So in this query right over here, I have 3 columns right now. Hit enter. We still get an internal server error, but notice over here that we forgot a comma. Let's hit it again. And we get a 200 OK response. And if you notice over here, it says, congratulations, you solved the lab. And what that means is that the number of columns in this query matches the number of columns in the query that is responsible for filtering based on category. And so now we've determined that the number of columns is equal to 3. So that's the first way of doing it. The second way was using the order by clause. So order by. So what this does is it'll order by the first column. So Control U to URL encode, hit send, and we get an invalid request. And that is because this was incorrectly done. Here we go. Hit send. Is it enter? Sorry, space. Okay, perfect. All right, so this is ordering by the first column. This is much better to do through the browser because you could actually see it order the results. So we'll do that here instead of the proxy. Okay, so notice over here, nothing got ordered, which leads me to believe the first column is one that we don't see, which is likely to be the ID ID column that uniquely identifies the gift items. So let's try 2. Now 2 should be this column over here. So these entries should be ordered based on the first letter of the alphabet. And we saw that happen over here. Perfect. Now let's do 3, and that should be the price column. So it should be ordered in ascending order. And here we go. So you've got 27, 45, 98, and 99. Perfect. So we know that there are 3 columns. Let's do 4. And we get an error. And the reason, again, we get an error is because chances are the query threw an error that this column does not exist or is out of bound, and this resulted in an error at the application level. All right, so now we know that the number of columns is 4 minus 1, which is 3. So we've successfully completed the end goal of this exercise by exploiting it manually. Now let's try and do this using a script. And again, if you're new to this channel, the reason I do this is because as a pen tester, you're going to come across many scenarios where you won't be able to exploit things manually, or it's a little bit unrealistic to exploit things manually. And that's why we always write scripts for all the attack vectors that we do. All right, the first thing I'm going to do is import the request library. And that library is responsible for making the get and post requests. Next, I'm going to import the sys library and the URL lib3 library. So we import these 3 libraries in every script that we write. I'm also going to add this line over here to disable any warnings when I'm running the script. So insecure request warning. I'm going to set my proxy. So what this line does, it sets a configuration for my script so that any requests I make go through my burp proxy. And this is very useful for seeing the requests that the script is making, and this way you could debug them in case things don't go as expected. So HTTPS. Okay, let's write the main method. There's 2 equal signs over here. Right, you've got to try and accept clause. Okay, so the way I want my script to work is I want to run it. So let's say script.py, and I give it a URL, and then it exploits the SQL injection vulnerability. So the first thing that I'm going to do is I'm going to set a URL parameter, so a URL variable, and take that from the command line arguments when running the script. And if I don't give it the correct number of command line arguments, so if it throws index error, I want it to print the usage and example instructions. So usage is argv0, and then an example. Name of the program, and then let's say www.example.com. And again, name of the program. All right, and then I wanted to end the program because I didn't run it correctly. All right, so let's run this, see if we get any errors. Hit enter. Okay, we don't get any errors, so that's good. So what happened over here is I didn't give it the correct number of arguments, and so it threw an exception. Instead of printing out the exception code, it printed out the usage instructions and an example of how to run the program. All right, that's good. Up next, if I gave it the correct arguments, I wanted to print a statement saying that it's trying to figure out the number of columns. And then I'm going to create a new variable, number of columns. And we'll get that value from the function exploit SQLi column number, and it takes in the URL. All right, so I'm going to write a function. We'll do that in a second. We'll write a function that exploits the SQL injection vulnerability in order to determine the number of columns. And if number of columns is not equal to false, so it evaluates to something I want it to print. The number of columns returned in the query. Let's just say the number of columns is, and then add it. So string version of number of columns. And then also add a dot because punctuation matters. All right, and otherwise, I wanted to print that the SQL injection was not successful. The SQLi attack was not successful. All right, let's remove this so that we have more space. Okay, that looks much better. All right, so now we need to write this function over here. So exploit SQLi. Again, it takes in the URL. Let's go back to burp to see how the request looks. And we'll make that smaller. All right, so the path is this one over here. Let's copy that. And then we'll do for I in range 1 to 50. So that's the number of columns that I'm going to try. The SQL payload. Let's just say SQL payload is equal to order by ask comment out, and then that would be the I value that we're at. All right, so what this means is that I'm going to iteratively try requests from 1 to 50 until I can successfully determine the number of columns that are being used by the query. Now 50 is an arbitrary number that I selected because I know for sure that the application won't have 50 columns. All right, so we need to make the request. And we know over here that it's a GET request, so .get. That would be the URL plus the path plus the SQL payload. And then we'll set verify to be equal to false because I don't want to verify certificates. And then proxies is equal to proxies because I want this request to go through my burp proxy. All right. And then we'll take in the response code and set it into the variable res. And then if we see in the response that it has the string internal server error, then we'll return I minus 1. So that's the number of columns. Otherwise, we'll keep iteratively increasing the I value. And then if that doesn't work, we just return false. All right, So what the script is going to do is it'll start with I is equal to 1. It'll test it out. If it doesn't get an internal server error, then it'll increment I, so it'll try 2. Again, so it timed out over here. We'll fix that in a second. If it doesn't get an internal server error, it'll try 3 and so on until it gets an internal server error. Once it does get an internal server error, that means that column does not exist. We can't order by that column because it does not exist. And so the number of columns that are being used by the backend query is I minus 1. So that number of column that we're currently testing with, minus 1. All right, so we're going to have to reload this because it timed out. And then we'll run our script. Let's clear this and give it the URL. So that's the new URL. Let's copy it. And that did not copy right. Okay, here we go. Hit enter. Let's see if we get any errors. Okay, good. We don't get any errors. It's trying to figure out the number of columns right now. And I'm noticing right now that this is not URL encoded, so this is not going to work. So I'm going to stop this before it tries 50 times. I'm going to clear it. And let's URL encode this. So the spaces, you use plus signs. All right, so this should work. Let's try it one more time. And it's taking an unusual number of times, which leads me to believe that this is not working properly. So this is when burp comes in handy. I'm going to look at the requests that it's making and try to figure out why it's not working. So you could see it's already at number 33, which is clearly not correct. So let's look at it. And again, I want it side by side. Okay, here we go. So this is what's wrong. We've got 2 slashes, one that we added. So if you clear over here, one that we added in the URL, and then one that we added in the path. And so it can't seem to find it. Let's remove that, hit save, and then run the program again. So you could see it's making, here we go. And that worked. So it says figuring out the number of columns, and the number of columns is 3. So let's look at that over here. You'll see it ordered by the first column. It got a 200 OK response, so it increased the value of the parameter I, and then it did 2, and that still got a 200 response. It tried 3, that got a 200 response. It tried 4, it got an internal server error, which means that we tried to order by a column that does not exist. And so the number of columns would be 4 minus 1, which is 3. All right, so we've successfully completed the exercise. To recap, in this video, we first manually ran a SQL injection union attack in order to determine the number of rows that are being used by the backend query. We then scripted that exploit so that it automatically does that for us. In the next lab, we'll learn how to determine the type of data that is stored in the column, which will eventually help us run an attack that will end up with us extracting information from more interesting tables, again, like the user's table that has hashed passwords in it. You can find the link to the script in the description. If you liked the video, hit the subscribe and share button so that it reaches a wider audience. Also comment below what you learned in the video and what you would like to see more of in the future. See you in the next video.